in the previous session, Dr. Chen gave a very nice introduction for the joint point analysis. And in this application session, we can run the program together using some example data set, and it would be fun. So some of the introduction here in my slide is overlapped with Dr. Chen's session. So I will just go through very quickly. So joint point regression model is used to detect some significant changes in time series, and often used to look at the trend in incidence or mortality rate of some disease, such as cancer, and also some prevalence rate. But not just this. I mean, basically, you can look at any time trend in any rate as you wish, as long as you have that set of data to look at it. So in the joint point regression analysis, basically you want to find some change point of trend. So identify such point which will break those time series into some distinctive period. And this method is extensively used in many research, time series analysis, used in the health organization. So the joint point regression software is available in this site, and this program is already installed on your computer here. But you can also go to this website to look at to download the software. So currently, yes. So this is the current version, 4910. And the one limitation of actually this program is that this works only on Windows machine. So if you are a Mac user, you cannot really use this program on Mac. But then the way you can use is that you can have some virtual machine installed on your Mac, so that you can use run some window-based programs there. And I'm using Mac, so I using parallel software to install run some joint point regression analysis. Now, of course, in this site, oh, sorry. I don't see that so much. Okay. So yes. So again, so as Dr. Chen said, so joint point regression analysis is basically to find that some continuous piecewise linear or exponential trend, and then identifying that those points, and then also the change rate. So here is the workflow of doing the joint point regression analysis. So to use this program, you have to create your input data file in a certain format. So you need the time, independent variable, usually year, and then some rate. That's going to be your dependent variable. And sometimes your rate may have a different standard error. So then you can provide the standard error for such rate, or sometimes you can actually calculate from the program. I will show you in a minute. And then other covariate, it's basically some stratifying variable that you can include, so that you can look at the trend in all these based in some subgroups there. So setting the parameters in the joint point program. So there is an input file tab you will see in a minute. So in this input file tab, you will specify some file format and also some setting for the model. And then there's a second tab for the method and parameters tab. And here you can do some joint point setting and also model selection method that you saw in the previous session, such as permutation test or the Bayesian information criteria method. The third tab, there is some advanced analysis tool options that we can also look at together. And once you have the setting for all the parameters, then you can run the point regression program. And then the last two, we can look at the result and then interpret and then see how to save the result. So we'll go through all these details when we run the program together in a minute. Okay, so before running the program, there are a couple of things that I want to note. So the join point. So basically, you find that the join point where that the trend has some changes, and then two segments will join at that join point. And each segment is going to be linear, but there are two options you can choose in the program. So first, there is a linear model on the original scale. Y is equal to like a plus b times x. And when you choose this model, you will estimate this intercept a and then the b coefficient here. And then in this model, the parameter coefficient b is basically saying there's some constant change between the year within that segment, right? So that's like a linear model. But then there is another option you can choose. That's the log linear model. You already saw in the previous session. So in this model, basically, you take the logarithm on the dependent variable, and then you are looking at the linear trend on the log scale there. So using this model, there is one advantage of using this model is that the log linear model will provide you the quantity, annual percent change quantity, which is a way to actually characterize a trend in rate over the time. So how do you compute that the annual percent change? So this is the formula you would compute the annual percent change. So rate at year x plus 1 minus the previous year rate divided by the previous year times 100. So using the log linear model, the y will be that the exponential of the a plus b times x, right? So just plug in that form here. Then with some algebra, you will get this, right? So if, using that log linear model, we'll estimate this coefficient b here. And then using this b, you basically compute that can get the annual percent change given that that segment, right? And Joinpoint program will provide this estimate when you use the log linear model. Okay, you already saw this table. So another point I wanted to make is that, so basically, how many number of join points you would allow in the analysis? And then obviously it will depend on the length of your data, right? And the maximum number of join points would get higher when you have more data points. And then this is the default set in the Joinpoint program. And in theory, they allow 9 join points as a maximum. But then you have to keep in mind that it may take quite long to run the program. So usually, 9 would be too much. Okay. So now we want to run this example data set together. You got the data set from the Monitoring the Future data set. Did you guys download the data set on your computer? So if you go to Google Drive, you have that this workshop folder. And then if you go to module 2B here, you can see that the folder data set. So there are 4 data sets I provided. And do you see? Okay. Then now let's open the Joinpoint. Oh, okay, before that. So it goes back. So what we are going to look at from this data set is the data has from year 1991 to 2019. And we are going to look at the trend of the cigarette smoking prevalence with the 2 different measures. So one measure is the past 30-day use, and then the other measure is going to be daily use. And we are going to do first by grade and then also sex. And then I have another data set later you can run on your own. And that's like by grade and race. So let's try with the grade sex data set. So it click that the I cannot see. Okay, I mean, it's okay. So I will open this data set in Joinpoint. Okay. So if you click the first new session here, you can go to your folder. Then you can choose the data set. For now, I'm gonna do this biceps, this variable, this data set. It doesn't make the expand. Okay, that's fine. Oh, this was the biceps.
Okay, thank you.
Okay. So everyone got the program on?
No.
Oh, no, okay. I will give you more time. Anyone need help?
Here. So yeah, I wasn't taking what we were doing. I was trying to get the data on the computer. So I don't know how to get the data into the Joinpoint.
Okay, can you help me?
Data. So I need to download it. So it might be. I can move it to the desktop. So now it's on the desktop.
Oh, okay, okay, yeah.
So. Great.
Same problem. I need to figure out a way to download the data. May take me a few minutes.
I'm trying to pull up the drive, but it says I need access. Here. Yeah, yeah. Let me look.
So you know, register. I clicked it, it made me log into Gmail. It was complicated. Yeah. And so I requested access to my Gmail.
The M plus. But M plus you have to write some.
Have a personal email as well. I can use the data to a non-NCI email.
Oh, I thought you were saying try the access.
The actual data set, right?
Okay.
Carolyn, isn't that website that log in that's run on the website?
You have to download the data set.
Okay.
I was having trouble getting the data set.
You don't need to enter anything.
Trend dot y
Perfect. Thank you.
IO.
No, no, no. She didn't even write the day, the month, anything. So that's what. And now I remember I told Kathy that let me make all this, but she didn't let me. She said,
not labeled very well.
he was, can you open this?
should be removed from water and then she can edit.
By sex.
Okay, you can just go down. I'll make sure that the problem. Yeah. They had to be keep. And then which one? Then I remember. I don't remember if it was 2 hours an hour, but I told them that we need. I was telling her. So now if you're going to make sure. Okay. She wanted to come and show her that.
Everyone done? Get the data set?
She understand that part.
Okay, can we move on? Okay. So now the first part is the really like the format of your table. So this data set was created as a CSV file. So it was delimited by comma, and the missing character was going to be space, and then 1,000 separate comma. So this, I think they automatically detect your data format. And then this data set has the first year, that's going to be your independent variable to look at the trend. So independent variable, your year, okay? And then prevalence, that's the one we want to do some trend analysis now. So let's do the prevalence. So here, in our case, we provide that the prevalence in the data file. So we can choose this one. But sometimes when you do the like age adjusted rate analysis, sometimes your data file would have like a number of count and then population, and also some age, the standard population, and then like your age group. So in that case, you can do some chooses calculate from data file, and then you can specify what's your count variable, and then population variable, and adjustment variable would be your age in such case, and then standard population, so that they can compute that the age adjust rate for you. Okay, but in our case, it's provided by in the table, and this is a type of variables. It allows age adjusted rate, crude rate, percent proportion, and count. In our case, we are going to the percent here. And then you have to specify what variable is going to be your dependent. So choose the prevalence here. Okay. So now next is the standard error. So in our case, we have the standard error variable here. So we have that the standard error for each prevalence value here. So you can click this provided, and then put that the prevalence here. Oh, sorry, prevalence here. But then sometimes you don't have that the standard error, and then you may assume that oh, it's just a constant variance. So that's can be like your choice for this like some data analysis. But then sometimes you don't provide that the standard error yourself. However, you assume that your dependent variable has a Poisson distribution. Then you can actually choose the Poisson variance as an option, so that the program can actually do incorporate some Poisson variance from your data set. And then also this is the new feature I have noticed. It's a beta version, so they are still testing. And it seems that you can also now try some variance covariance metrics specifying for the incorporating this analysis. But I haven't really tried this one, so I don't know exactly how it works though. So in this example, the standard error was provided, and we have this, you have to specify which is the standard error variable. So you can do this. Now, the error. So in our case, we don't really think the data is each like autocorrelated each other. But then sometimes in your analysis, if you believe or like some assume there is some autocorrelation in your data set, such as here, they don't have like a nth order, just first order autocorrelation, which means that your current rate may get like affected from the previous rate. So that's like a first order autocorrelation. So you can choose this option if you assume or believe that there is some correlation in the data set. So in our case, we just choose that uncorrelated. So now variables. So here we want to look at the trend by measure, which is the past 30-day use versus like the daily use, and also by grade and also sex. So I would choose all these categories. So then basically, you are going to see that the trend in the stratified analysis by looking at all the combination of these three variables. Okay. Now here's the two options you can choose. So the first is a log transformation. First is just a linear model on the original scale. And then the second is the log linear model. And then we usually prefer to that log linear model because that provided the annual percent change, which we usually is interested in to look at it. Okay. All right. So that was the first input file tab here. Now go to the second tab. And of course, like if you want to see that the more details of this feature, you can click this link. Then you can have like more detailed explanation about these options. So now in the second tab here, so I think that currently only available for the grid search. Like there are two different algorithms that they used to have before, but now only the one algorithm. The first tab here, so that's the minimum number of observations from a join point to either end of the data, and then default set as 2. So which means that by setting 2, you are not going to pick the join point from the beginning. You have to have like at least 2 points from the beginning end to have the join point. So which means that our data set was starting from 1991. So by putting 2 here, we are going to allow that the join point to potential join point to like start from 1993. Okay. So it cannot be like 1991 or 2 because we said that's a 2 like as the here the setting. But of course you can change the setting if you want. Like there is an option like this. Okay, the second one is that now minimum number of observations between 2 join points. So that means basically you don't think that the one is going to be enough for to like really look at the change of the trend. So at least there should be 2 points between the join point. So that's what like this setting. But of course, sometimes you would say you would feel more comfortable to have more number of the data point between the join point, and you can make such changes if you want. Okay, so now the third one is it's a little we don't really use this option, but it's a number of points to place between the adjacent observed values. So in usually when we do the join point the regression analysis, we just look at each data point, the change at each data point. But sometimes you may want to like look at the change in the middle, right? So if you put like 1 here, that means you would allow that the having join point between the midpoint and between the observed point. So for example, like it can be like join point can be like 2000.5. instead of either 2000 or 2001. But I don't know if it's really practically useful feature though. So default is usually 0, so that we are looking at the join point that observe the data point. Okay. So now this one also, as a default, we don't put any threshold for the minimum percentage change here. But sometimes that in some application, they may assume that they don't want to like look at the too small changes. So if the like change was below some certain threshold, then they may think that, oh, that's not meaningful in reality. So they may set some like threshold for the minimum like changes in the trend. Okay. So and then this is a number of join point to use that like a minimum from 0 to 5. This is default. And then do you remember that there was a table that you saw? This was like based on the number of determined based on the number of data points. In our example, we have from 1991 to 2019. So we have a total 29 data points. So you saw that as a default, they put 5 if the data point is more than 27 points. So that's why here was 5. But of course, if you want to increase or decrease, you can set as you wish. And then now the AAPC. So this is the average over the annual percent change. And often, I mean, you can look at the average APC for the entire range, but also we usually do like we want to look at the more like a recent change, the change. So then you can like say, I want to look at the average annual percent change over the last 5 years. Then that's going to be like 2015, 2019, or like 10 years. It's going to look at the 2010 to 2015. You can also look at some specific range for the average annual percent changes if you want. So for now, I'm going to just go to the 5 years of the last change here. Okay. So, and then model selection method. So as you saw in the previous session, I mean, there are like multiple options you can choose here. And then there are indeed lots of theory behind of this method. So sometimes it's not clear like which option would be the best. And then I would say probably there's no single answer for that. And permutation test, that's the like test was included in the very original version, and then it stays until this new version. And then after that, so permutation test is basically based on their simulation study. It was quite reliable. So it provides reasonable estimate for the number of join point. So I would say my recommendation is that you can start with a permutation test in the beginning. And then, of course, then you can play with other methods and then see if that makes any difference or not. So permutation test, and then there is a traditional BIC, it's a Bayesian information criterion method. And as you saw in the previous session, the permutation test is the sequential test. So you are like testing, like first start from the minimum and the maximum. So zero join point model, and then in this case 5, so 5 joint model. And then you just do some significance test. And depending on your test results, then you move on to the next one. So if you reject that the 0 join point model, then you would increase that the minimum as 1, right? And then test the 1 join point model and then 5 join point model. So then see again to the some test. And then if you again reject that the 1 join point model, then you would increase the minimum like 2 to 5. So it's like sequentially you are testing the models. So then, of course, if you have like many join point to test, then it would take some time. So computationally, it can be quite intensive. So that's one downside of the permutation test. So then later, like they were they developed this new Bayesian information criterion method, which was basically you are computing that this BIC under 0 join point, 1 join point, and then 2, 3, 4, 5. And then you are picking that the one that gives it the minimum Bayesian information criterion. So computationally, it's less expensive, the less intensive. So it can be quick. But then, of course, there are some, in the performance, there are some like, not issue, but some situation it works fine, but then some situation it may overestimate. So in the general recommendation, they are saying is that permutation test usually work good for the medium or large changes. And in that sense, it's kind of conservative. So you don't like really detect all like small changes over the time. BIC here, on the other hand, it's more sensitive to the changes. So it tends to detect more like small changes. So then potentially it may overestimate some changes here. BI3, that's the also like Bayesian information criterion, but with a little bit different penalty term here. It seems that the BI3 actually provides similar results to the permutation test with a less intensive computation burden. And this is something else, modified BIC. It seems like they developed this for some specific application, but they don't really recommend this one for most users. So now, after this, they also developed a new method here. And you see that these three methods is all with some this star like asterisk here, right? So that means it's still beta versions. So they are still doing some tests. So it's not final yet. So here, this is a data-driven BIC method. Weighted BIC is the basically based on the data. It's the average of the BIC and BIC3 method. And the data-dependent selection is like based on the data. They do some like pre-step, and then they decide which one works better, like BIC versus BI3. So this is kind of new features they added in this version. And so I didn't try myself, so I don't know exactly how good it is, but you can try if you want. And then weighted BIC out, that's also, it seems that this is not also for most users, it's something like for some specific application. So you can read more details when you link this here. Okay. Right. So, and then the last piece here on this under this tab is the APC, AAPC, and tau confidence interval. So we usually had only like parametric method before. So the APC was based on some T distribution, and AAPC was based on some normal distribution. And then they developed a new method, which is the empirical quantile. Again, this is a still beta version. You can learn more about this by going here. All right. Now, so far, do you have any questions so far? Right. Good. So now next to go to the advanced analysis tools here. So there are three options here. First, no advanced analysis. That means that you are going to just look at the trend in the each subgroups stratified by your covariate. Okay. The second one is the pairwise comparison. So if you click here, there are two pairwise comparison here. So first, like parallel means that if you are curious, like wondering about that the two groups, some specific two groups, and then see even if they have a different absolute level, whether they have that the same trend or not. So that's like a parallel testing. And the coincident here, not just the parallel, also the absolute level is if it's the same or not. So you can make some comparison between like two groups using this option. So that's a pairwise comparison. And last one, this is actually a new feature in this recent version. So this is jump model or comparability and ratio model. And then this is actually some specific case that such that there's some like a systemic change in the data collection. So for instance, in the Dr. Chen was mentioning about some like ICD-9 to ICD-10 code change, right? That's an international classification of disease coding. So when there is some like systematic change in the data collection, you may see that certain like jump in like from one year to the other. So in such case, the standard the regression, the joint point regression analysis may not be the may not capture the real trend in such case. So in this jump model, you can incorporate that when that happened, that change was happened, so that this program can incorporate such changes in the trend analysis. And we are not going to touch on this today with this one, but you can again learn more about this when you go to this website. All right, so I think we are set. So let's first try the no advanced analysis, and you can click this one, execute current session. Either this one or this one, yeah. Click.
Yellow thunderbolt that you just clicked?
Yeah, so I think both is fine, but I think this one is like suppressing some warning messages. So maybe this was maybe better. You can either, yeah.
Sort the data, so it says, independent variable, sort it here, for example,
So the problem is that without previous research, then some of them kind of have not.
chart.
So input line, yes. Oh, here.
So you can see what
You all got the result?
So
So did everyone got? I get the result here. Okay. So now let's go through this result here. So the first one is among the for the past 30-day use prevalence, first grade, and then female. And then you see that there are like from 0 to 5 point joint point model. And then with the star here, that's the best fit. So that's the final selected model here. And so it seems that for past 30-day use prevalence among female Turks grade joint point model is the final model. So you see that from 1991 to 1997, it has been increasing with the annual percent change of the 5 point. Okay. And then the second segment
is from 1997 to 2013, it has been increasing with the APC minus 5.8. And from 2013 to 2019, it was pretty big drop, right? Oh.
Thank you. So from 2013 to 2019, it decreased with the APC like minus 15. So it's pretty big drop from 2013 to 2019, right? Let's look at the male. So male actually shows that the more segments, 3 Joinpoint model was the best one. And you can see that from 1991, 1997, it increased with APC 5.09. But then since then, it has been decreasing. And then from 1997 to 2006, it was decreased with APC minus 5.6. And then it was kind of slowed down in this period. And then after, from 2012, again, it dropped pretty quickly, right? So, and then you hear that in this result, the asterisk here, that means that this was a statistically significant. So in the middle part, the third segment here, it doesn't have that, it doesn't say that the US actually significant, statistically significant trend. So we cannot really say this was actually true. So this is the figure, and then you can see that the whole result here for different combination of these three categories here. So now this is a graph. So here's the data. So let's look at the first one. Okay, so here this data point has like year, and then this is the observed prevalence that in our input data. And this was a standard error again we provided through the input data. And then this is the model prediction from the Joinpoint. And then these are the Joinpoint section here. Model estimate. So these are the summary of these estimate here. And then you see that the Joinpoint 1 and 2, which is a 1997 and 2013. And then this is a standard parameterization and then general parameterization. So standard parameterization is that the one that you saw in the previous session, that there was a beta and then delta alpha, right? So those are the these are those estimates of those coefficient.
Sorry, question. The observed prevalence is almost like would be the unadjusted prevalence, and then the model prevalence is adjusted for sex and.
No. So observed prevalence is actually our data set, input data.
Okay.
So that the data set we put as to run the model. So that's the observed data. And then this modeled prevalence, that's the like from the Joinpoint fitting. And so Joinpoint regression, we don't do the adjust for the other covariate. We cannot do that. What we can do is that we stratify that data set into some like subgroups, and then look at the trend within that subgroup. Yeah. Okay, and then this general parameterization is actually to get the intercept and then the the intercept and then slope for each segment. So here, like in the 2 Joinpoint, we have this segment, right? 1, 2, 3, and then first segment, the intercept and this slope is this one. So this is the intercept and then this is slope. And the second segment has this is intercept and then slope here. So this is basically the slope. That's our like D estimate. And your APC is going to be the exponential of this estimate minus 1. That was your APC. So you can check that the exponential of this minus 1 provide this APC 5.2. Okay. And this is a second segment, and then this is a third segment here. And then we looked at the average APC over the 2019 to 2000, last 5 years. So from 2015 to 2019, and then this is the average APC over those 5 years with the confidence interval this. Okay. So how you get this output to like display your result? So what I usually do is that, so this is the data point I have. So I can actually highlight and then copy, and then I can save these into Excel file. And then I can read those file in any program. I usually use R, and then I can just use some ggplot to plot this result for your paper or for your report, whatever. But also there's some like graph here. It seems like you can also export this graph into some file. That's one option. And then also you can print some of these results into some like report format. So you can do like things by doing this. But I want to show more things here. When you look at this result, you can actually filter, display your result. So currently I'm showing all models here. But if you don't want to see that the all result, you can actually just click that the final selected mode. So then you just show only the final models for each. And I think this is actually pretty useful feature. So you can also do the multiple models simultaneously. So if you apply this, you can check, click multiple ones. So let's see, I want to see the past 30-day use among female, but the different grade at the same time. Okay. So then you can see that the trend among the different grade for females like this. Okay. And then also you can do, I want to check, look at the male female side. You can also click this way so that you can show that the female versus male. But this is pretty handy feature, I thought. Okay, so any questions so far? So if you click filter here, this filter control, and then the last one, display options.
Oh, thank you.
Yeah. Then you can apply. Yeah. Okay, good. So any questions so far? If not, we can go to the next data set. So, first of all, you can, if you save this result, you can save this one as like a Joinpoint output. It's going to be saved as a JPO output. So if you save this one, you can read it again later without running, without rerunning your analysis. So you can do that. And also, at the session here, you can also save this session as like a Joinpoint session here. So you can also save this session so that you can rerun later using the same setting. All right, so now I want to try that advanced feature of the pairwise comparison. And I'm going to use that the subset of the data set that we just used for this analysis, because currently we have a measure and grade and sex. So I was like running just by itself, but then it got crashed. So I have a feeling that you have to actually have like simplify your input data set to run the pairwise comparison. So if there is a data set in the folder, you can open, so let's look at only the daily user here. Okay. So then this is all like daily user. So I want to compare in each grade, I want to do some comparison between male and sex, female and male. Okay. So let's try again the same steps. So I'm gonna do percent prevalence. Look at the prevalence trend. Standard error was provided, and independent variable would be year. So now, within each grade, I want to do some comparison between sex. And I'm going to just use the default setting here for everything. Now, advanced feature, let's just like a pairwise comparison. So I'm going to try to see if there is any parallel pattern between male and female in some grade here. On this. Okay. So could you guys run the analysis? So here's the result here. So you see here, the first one. So within the 12th grade, we were checking if there is any parallel pattern between female and male here. And they checked under the assumption of parallel and not parallel. And then they chose not parallel is the final one, which means that they didn't find the evidence like to say there is some parallel pattern between female and male in the trend. And here is the female male, like 2 join point, 3 join point, which is actually the same result as before when we run that separately, right? And then 10th grade also, they say it's not parallel. And 8th grade, now the 8th grade actually. So see here, among the 8th grade, male and female, they think actually they couldn't reject the parallelism, which means that this pretty similar trend between male and female. And then these are the APC for each segment. Okay.
Clarify. The parallel is you're running both the female and male data sets using the same selection of joint points and network locations.
I mean, they are checking if the male and female have the same number of join points and also the same location and also the same APC.
So basically when you get a result, again, looking at the ones with stars on them, those are the best fit functions.
Yes.
So that then indicates that you can use this.
So they are checking that the first, like, if it's parallel or not. And then once they reject, it's not parallel, then they would run separately for male and female. And then, yes, right, yeah. So then in the 8th grade, it seems that they say it's pretty similar. They have the pretty similar trend between male and female. So, and that's the result here. So now in this case, we are going to be also interested in, then can we say actually they are identical, right? So I'm going to try in this case, I'm going to try the coincidence here. It takes a little time. I'm running that whether those 8th grade, male and female, they are actually identical. So let's say here. Oh yeah. So even they conclude that they are identical, the male and female. I mean, yeah. So it seems like the 8th grade daily use prevalence among male and female, they are very close to each other. Right. So, and so I can give you like 10 minutes. There are another data set, which is the by race. And actually, I'm not sure we have enough time. Okay, I will leave it for later. So this analysis was recently published in the paper. And I'm just gonna go to the summarize of this paper. Okay. So this MTF Joinpoint Trend Analysis in MTF dataset by grade and sex and race was done, published in this like JAMA Network Open recently. And then you can see that this is like a typical way we present a result. So here, past 30-day use among girls and boys. And we put that the 12th grade and 10th grade and 8th grade in one figure so that we can see that the trend by different grade among the girls and boys here. And you can see that here for both like daily smoking and past 30-day smoking, it has been like increasing in the earlier years, but then has been like decreasing after that. But then there's some like a big kind of rapid decrease starting like about 2011 here in all grades. I mean, there's some like increasing here, but actually it was not statistically significant. So we cannot really, it cannot guarantee that this is actually a real trend here. But the message from this analysis is basically showing that, so the past 30-day and daily use of cigarettes, and they also did the smokeless tobacco, look at the trend of the smokeless tobacco use, but the data set we just used was only the cigarette use. So both these decreased more rapidly since 2012 here, when the e-cigarette use was increasing, the usage was increasing. And it's currently like very low prevalence among the adolescents here. And one motivation of this study was to see, I mean, we know that the e-cigarette has been, use has been increasing like since 2011, but then we don't know what's the impact of such increasing usage of e-cigarette on the other tobacco product use. So wanted to see that the trend of the cigarette and then smokeless tobacco use among the adolescents here. And it's still controversial, like if the e-cigarette use is a harmful or benefit, right? So there's some concern that the e-cigarette use can be a gateway for the regular smoking. So basically, like initiate the smoking. So there was some concern about that. However, on the other side, the e-cigarette also can displace the smoking, right? So some people may use the e-cigarette instead of smoking, who like otherwise they would have smoking, some cigarettes, for example. Or like some people may quit smoking using the e-cigarette, right? So there is like some two sides of the story about the e-cigarette use, and still is not clear what's the truth, and maybe both actually, right? So by looking at this analysis result, of course, this study didn't exclude such possibility of the e-cigarette use as a gateway to get to increase the smoking to the smoking. However, by seeing that this rapid decrease since 2011, at least this result suggests that that role of e-cigarette as a gateway may not be the dominant factor at the population level. So that's why, like, despite its recent increase in popularity, e-cigarette use does not seem to be a contribute that does not like stop the decrease in the tobacco use prevalence here. Okay, so this is like the typical way to present the joint point regression analysis result. But then another typical way to present is the table, like summarizing the table of the result. So you have that the trend and APC, and then the corresponding year of those APC, and then also like report that the average annual percent change over the some years. So this is also a typical way to summarize that the joint point regression analysis. Okay. Right. So we have 15 minutes.
Is there any way to indicate in the options you showed us how to account for complex survey weights if we want to use like national survey data like this?
That would be nice. But no, I don't think, I don't think this program can, incorporate that.
Related to that question, the data file that we added to the software, the prevalence and the standard errors, I assume, come from weighted estimates.
It is true. Yeah, that's a good point. So indeed, you can actually calculate the rate incorporating the weight. That's true. Yes. Mm-hmm. Mm-hmm. All right. So any questions? Okay. So we can wrap up this session with some like summaries and conclusion. So joint point analysis identifies some trend, the significant trend changes over the time, and the trend or like slope of change at the joint point. Each segment can be linear either on the original scale or log scale. And the number and location of the joint point will be determined by model fitting to the data. And minimum and maximum number of joint points can be selected by user. But then, of course, like when you put that a large maximum number of joint points, it may increase the computational burden significantly. So just to keep in mind that that the consequence of having like a large maximum number of joint points. Okay, so now model selection method. So permutation test has the longest history, and then it has been proven based on some simulation studies. It's pretty good to detect the medium or large changes, and it's also quite conservative in the sense. And it actually reasonably perform well to predict the correct number of joint points. But then it can be computationally intensive if you have like long many data points to analyze. PI3, it seems that it provides similar result to the permutation test, but with a less computational burden. BIC is better, better performed for small change detection, but always you have to think about the potential overestimation when you use the BIC method. And then these are the new method they just added. It's beta versions. And the weighted BIC is the weighted average of BIC and BIC3. It would be determined by the data. And then data dependent selection. So it will choose either BIC or BIC3, again, depends on the data set. And then they said that this weighted BIC art or modified BIC, it was included for some specialized purpose. I couldn't really find what specialized purpose myself, but usually it's not recommended for the most users. So you can probably, you don't need to worry about. So more examples are available on the website. So in this example, we just use the input data and the format that is specified for the joint point program. But if you are interested in some cancer incidence or mortality analysis, there is a nice program. It's a CRStat, and there's a way to actually extract the data from the CRStat and then save it as some dictionary and then some text file that can be directly go to that joint point program, so that you don't need to make that specific data format for the joint point program analysis. So here are some like examples you can go through from the website. It would be pretty fun to go through. Okay, so I think that's all I have. And thank you for your attention.